Hi, Assalamualaikum and very welcome for those watching this video, especially Miss Sam, our physics lecture. So, in this video, me and my group members are going to present our laboratory experiments or experiments 4, which is linear motion. So, let's start with definition first.
Before we proceed further, let's understand what linear motion means. Linear motion is the motion of an object along a straight line. In this type of motion, the object moves from one point to another in a single direction without changing its path. This experiment was carried out with two main objectives. First, to investigate the relationship between force, mass, and acceleration. Second, to determine the acceleration of an object under a varying force.
The theory of this experiment is Newton's second law of motion states that force is the product of mass and acceleration. The equation is F equal to m times a. In this experiment, two masses m1 and m2 were connected by a string. m1 is a smooth table while m2 hangs off the edge as shown in the diagram. When m2 is released, both masses accelerate together because they are connected by the string. The acceleration of both masses is the same and the string is assumed to be massless and inextensible. Force acting. On m1, tension in the string pulls in horizontally. On m2, gravity pulls it downward. Tension pulls it upward. Using Newton's law, we can write equation for the force, where for m1, T equal to m1 times a. For m2, T minus m2 times T equal to minus m2 times a. Combining this equation gives the acceleration of system, where a equal to open bracket m2 divided by m1 plus m2 close bracket times g. Here g is the acceleration due to gravity. Key formula. To find the acceleration experimentally, we measure the time it takes for m1 to move certain distance. Using the formula, using the equation of motion, where s equal to 1 over 2 times a times t square. Rearrange give a equal to 2s divided by t square.
So let's set the apparatus to conduct the experiment. First, we need a track rail, blower and pressure tube, gliders, flag, photojet, masses, mass hanger, string, and pulley. So, the first step is the linear track set was assembled. Second, the pump was switched on. The air was allowed to flow through the track for several minutes. The track was balanced by adjusting the screws on the legs so that the glider was kept stationary and was not glided to either end when released. Next, one hook was inserted at one end and a flag was placed on top of the glider. Fourth, the mass of the hanger and the mass of the glider were measured and recorded. The length of the flag was so measured. And next, one end of the string was attached to the hanger and the other was connected to the glider. After that, masses of 20 grams were placed on the hanger and 80 grams were placed on the glider. The string was positioned over the pulley. Next, the glider was positioned exactly before the photojet. Then the glider was released and the time shown on the photojet was recorded. Next, the step was repeated 2 more times to obtain average time values. Then, the slotted mass on the glider was reduced by transferring a 20 gram mass to the hanger. Step 7 and 8 were repeated. And the last one is the procedure was repeated 3 more times with 20 gram of the glider slotted mass added to the hanger. So, from this result, we can conclude that the highest weight of hanger and slotted masses is 0.795 and the acceleration is 406.67 meter per second and the least is 0.206 for the weight of hanger and slotted masses and the acceleration is 110.91 meter per second. So let's move to the analysis of data. This is a graph of force versus acceleration. We know that the gradient of the graph represents the mass of the object, which is equal to 0.0195 kilogram. So what does the graph tell us? The graph of weight force versus acceleration shows a linear relationship. This indicates that the weight force is directly proportional to the acceleration. As the acceleration increases, the weight force also increases consistently. The behavior aligns with Newton's law of motion, where force is the product of mass and acceleration. The graph demonstrates how greater acceleration results from a greater applied force for a given mass. To calculate the uncertainties of gradient M, the formula of uncertainties of gradient is 1 over 2 times maximum gradient minus minimum gradient. Since the maximum gradient is equal to gradient, hence the answer to this of M is equal to 1 over 2 times gradient minus minimum gradient, which is equal to plus 0.0052. Now, the relationship between the gradient from the graph and the total mass M1, we know that the gradient of the graph represents the mass, the gradient equal to the total mass of the system, and the gradient is equal to M1 equal to MT1 plus MT2.
The discussion of this experiment in this experiment is to investigate the relationship between force, mass, and acceleration. We can perform an experiment based on Newton's second law of motion. If the force varies with time, displacement, or other condition, the acceleration can be calculated by rearranging where A equal to F divided by A.
During conducting this experiment, there are also small errors that can occur, but the small error will not affect the result of the experiment. Among the factors that can be identified in this experiment is the presence of air resistance. This happens because the presence of water in the laboratory can affect the movement of the flag, causing it to move slower than predicted. In addition, the friction between the object and the runway surface also causes the acceleration to decrease. Next, inaccuracies in recording time and measuring the mass of object can also have an effect in an experiment. This depends on human response, which may not be uniform. Finally, the percentage error for our experiment is only 32.8%. In order to improve the accuracy in this experiment, some suggestions that can improve the data of the next experiment, such as using an automatic time measuring device that can measure time more accurately and using a modern weighing device so that the mass of the object can be measured properly. Next, close all air passage before doing this experiment to reduce air resistance that can slow down the object's acceleration. In addition, ensure that the surface of the track used is completely smooth and flat to reduce friction between the object and the surface. Finally, we know how to conduct the experiment so that the experiment runs smoothly.
In conclusion, from this experiment, the experiment demonstrated that the acceleration of an object depends on its mass and the force applied. As the applied force increases while the total mass remains constant, the acceleration of the object also increases. This experiment is closely related to Newton's second law, which states that the rate of change of momentum is directly proportional to the net force acting on the object in the same direction. Moreover, when both the mass of the object and the applied force change, the acceleration of the object will also vary. In conclusion, the experiment showed that acceleration increases with the increase of net force, consistent with Newton's second law of motion.